Exercise A01 is going to get us started working on our handy array library, a little program that is going to span over all the exercise we do in this module. And this is going to allow us to set the ground pretty much for this program. We are going to create three files, test.c, hall.h, and hall.c, which are going to be really similar to the setup we had in the apprenticeship exercise for our previous module, module 1 of 3. So we are going to get started by opening the Conqueror window. We are in a new directory here, ready to work on this program. I'm going to use a command line to create all of my files in one shot. You are more than welcome to use the graphical user interface by right-clicking here in Conqueror and creating your files one by one. I will need hal.h and test.c. So the touch command, just as a FYI, is going to just create those files completely empty, and then I will be able to click on them and open them with kwrite to be able to modify them. So let's get started with actually hal.h. Okay, let me resize this kwrite window here. What we are going to do is we are going to include here the prototype of the first functions we have to write. There we go, and we are going to use a trick that was explained during module 1 of 3, which allows us to prevent multiple inclusion of the same header file. So I'm going to use a symbol name here that would be hal_h. If it's not defined, I define it to avoid the multiple inclusion, and I have my pound and if delimiting what is going to be protected from multiple inclusion. And then I can go back to my description of the work to do. I have essentially two functions here: void int array display, constant data array, and int size. So if you don't know why we use a const keyword here, that's a good question to post on the forum or to double check in your textbook. So let's write this first prototype. Oops, wrong file. There we go. Void int array, and this one is a display. Const int data, I think was the name, int size. Let me double check and check the second one. That's correct. Void int array scan, and I should have called this parameter data as well. Why not, to be consistent? Void int array scan int data int side, and this time there is no const. It's the same thing. If you're not sure why, ask a question in the forum. Void int array scan, oops, int data, an array of integer named data, int size, and I'm going to copy, try to select only what I want here, which is apparently a problem. There we go. I'm going to select this and copy it because I'm going to reuse it in hal.h. So the hal.c, sorry. This is hal.h. I'm saving it. Let's go back to our Conqueror window. Hal.c. Here it is. I'm going to paste those prototype. Include double quote hal.h. You should know by now why double quote and not greater than strictly and lesser than strictly signs. And I'm going to make the body of those functions empty. Since those functions are void, they return void, I don't need to even put a return statement in there. I can save, and I have functions that do absolutely nothing, but at least will compile. So we have hal.c, we have hal.h, and let's move on to test.c. So test.c is going to include also, maybe if I can type in there, there we go, pound include double quote hal.h. I was going to type tools.h, int main. Okay, and this is a boilerplate code for our test functions pretty much. Okay, so we have right now nothing there, but this is where we are going to write the code which is going to validate all of our function developed in the context of hal.c. So let me go back to the original exercise. This is pretty much it for the setup. You see here's a job I'm going to have to do more specifically to test my function. And I'm going to now work on the development of the display and the scan function. So let me move to HAL.c. Let's start with the display one. With the display function, we are going to pretty much iterate over the array that is specified as parameter. And we are going to display every element of that array. So let me start by getting int I, an index variable. I'm going to use a for loop because this is a counter control loop, clearly. I'm going to initialize I to 0. And I'm going to iterate while I is lesser strict than the parameter size, and increment I at every iteration. After that, what I have to do is to display on the screen the content of my array. So printf element by element, I'm going to display %d, and I'm going to put a space after the number to make a display that is a little easier to read. And I'm going to display data index I. Actually, let me do something slightly different here. I'm going to even put the number between square bracket. This is just an aesthetic choice, okay? So I'm going to display the number between square bracket, and when I'm done, once again, this is just aesthetic. I'm going to display a new line so that I make sure that even if I call int array display several times in a row, each array is going to be displayed on its own separate line. And well, okay, we can test that already. I'm going to go to test.c, and I'm going to declare an array, my array, why not? I do not specify the size because I'm going to specify here an initializer. Let's put all the numbers from 9 to 1 in this array. And let's call our function int array display with my array as first parameter and the size of my array as second parameter, which is going to be here 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and if we don't have any more emails popping up, I'm going to save this file. HAL.h and HAL.c have been saved as well. Let's go back to our Conqueror window. Clear the screen. GCC HAL.c test.c. In function int array display implicit declaration of function printf. Okay, that's easy to fix. Let's go to HAL.c. Pound include stdio.h. That should make the compiler happy. GCC again, my file is saved. Yes, compilation works so far. Execute 987654321. It looks satisfying. Now, let's go back to HAL.c. We have to write the second function, which is the one reading data from the user. So we are going to do it this way. We are going to once again use an index variable. Once again, we are going to use a loop, a counter control loop using the for loop statement, simply because we know once again what is the size of the array. We know how many value we need to read from the user. And for each value, we are going to specify enter at index. I'm getting a little lengthy here, but %d, and I'm going to display here the value of my index. Scanf. Scanf what? Scanf an integer. Where do we want to store it? Data index I, prefixed by the ampersand. And then when we're done with that, we save. We go back to test.c, where we are going to ask the user for some information. And I'm going to use my array again, why not, to store this information. Int array display will allow me to make sure that everything has been modified correctly to reflect what the user typed in my array. Save, go back to Conqueror, And we are going to once again compile, execute. So we have our values. Enter value at index 0. Well, let's start with 9, then 8, then 7, then 1, 2, 3, then 6, 5, 4. Let's see. 9, 8, 7, 1, 2, 3, 6, 5, 4. So the array was correctly updated. And we are pretty much done with this exercise. Let me just pop back on the screen the content of how.c.